Hey everyone, this is Logic Coding. Today we're going to look at another Google interview question, car flood. This is more like a scenario slash application problem. Now let's look at what's the scenario. It's for any scenario-based problem, it's better to draw some visualization. So we are given n cars. They're going into the same direction along one lane road. The destination is target miles away, so we have a lane. While each car has a constant speed and an initial position, so we have some initial cars that is placed around this road, and for each car we would have a speed go with them as well. The scenario is while a car can never pass another car ahead of it, but it can catch up to it because it might have a bigger speed and drive bumpers to bumper at the same speed. After they catch up with it, it's assumed they have the same position. So a car flood is some non-empty set of cars driving at the same position and same speed. Note that a single car can also be considered as a car flood. And it asks us how many car floods will arrive at the destination as time goes by. Some clarifying question might be if it just exactly catches at the end at the destination. Will it still be a car flood? And the answer is yes. Now let's look at example. So the target is 12 and we have 5 cars with initial position 10, 8, just delete this, 5, 3, and 1. And for those 5 cars, I have 5 speed associated with them. So for the 0, I have 1. For the 3, I have 3. For the 5, I have 1. For 8, 4, 2. Okay, so for this scenario, how many car floods will we have? So for the first car, 2 meters away, it will need 1 second to reach to the end, followed by 8, 4. It will need exact 1 second as well. So this will become 1 car flood. Some interesting finding is that the behind car will never reach the destination first because it will catch up and then it will reduce to the same speed. So it either will form a new car flood or it will merge with the previous car. Okay, no problem. That's what happened with this one. The third car will need 7 seconds, while the fourth car only need 3 seconds. So what will happen is this car will catch this before it reaches to the end and form 1 more car flood. So this will be the second car flood. And since 1, it will need 12 seconds, it will never catch up with previous flood. So this will form a new car flood. So what do we need for this problem? So we need to sort according to its starting position, ideally paired with either speed or time needed to reach to the end. And then we need to start with the closest. By closest, I mean to the end condition, and increase car flood if needed time is bigger than current flood time. Okay, cool, that's it. Then the next question is what data structure and algorithm do we need to represent the scenario? For sorting, we can either do a pair and then use sort keywords, or we can directly use a balanced binary search tree which will be ordered map in C++ to search it. It will all have the n log n time complexity for sorting. That's pretty much it. Let's dive into the code. So as I mentioned, let's create a map with its position and time needed. And I just need to loop through all the cars and put its position associated with the time. Why I put a negative here is because I want to consider the closest to the destination, but 10 will be the largest value. So I put a negative here so that I can consider it first while using an ordered map. Associated with the time needed, which will be target minus its current position divided by its speed. Okay, cool. After I have the map, what I need to do is I need to traverse the map to see the items one by one. And while I traverse, I just see whether I need to increase my count number of car fleet as well as current time needed. Previous, I'll just set it to this. And at the end, I'll just return count. So if my considered second is bigger than my current time, then a new car fleet is formed. I increase my count and I update my current time into this new needed time. So the time complexity for this one will be dominated by the sorting algorithm, which is O n log n. And after we traverse this, it's gonna take us log n time, so O n log n. And the space complexity will be simply be O log n. Since we only allocate a map for this problem. Let's run this. Cool, nice, great.